Hello everyone, amateur meteorologist. First weather here is October 28th, 2020, and welcome to my 2020-2021 Winter Thoughts Part 2. Let's get right into it. As you might recall, in my last video, I did go into detail about what I thought would be happening in regards to the La Nina, the warm waters in the Northern Pacific, especially the PDO, the QBO, and the NAO. In this in this video series of my winter forecast, I will be discussing the MJO, Siberian snowfall cover, Arctic sea ice, recent trends, and also what the models are saying in terms of their thinking for this upcoming winter. So let's get started. First off, let's start off with the MJO. This is essentially a measure of convection along the equator, particularly in the western portion of the world, stretching basically from India all the way to the eastern portions of New Zealand the eastern portions of Indonesia. And right here you have four major weather models right here, and these are all predicting the temperature anomalies or precip anomalies for the entire globe for the December through February tri-monthly period. And what I want you to notice is the areas in blue or green or purple for this map indicate where areas where there will be above average precip or above average convection. And you can see that almost all of the models have their forecasted above average precip anomalies to really be focused to the southeast of India and then around Indonesia and just to the east. If you go down here, this model has most of its focus to the east of Indonesia. Same thing with this model right here, southeast of India and also all around Indonesia. Same thing over here, not as much around India, but more to the southeast and also to the east of Indonesia. Now, when you have that sort of consensus with all of the models essentially saying that the main areas of precip will be in this region right here, and you correlate that to the MJO, which basically is a measure of different areas of convection, because the MJO basically runs from phases 1 to 8. So you have 1, 2, 3, 4, 5, 6, 7, 8. You can see that those areas of forecasted above average precip anomalies line up with the 4, 5, and 6 MJO phases. So now if we correlate that to what goes on during the winter, you can see that all three of those phases are very warm phases for the lower 48 and especially the eastern half of the country. You can see that for phase 4, phase 5, and phase 6, all areas east of the Mississippi are warm in all three of those scenarios, while the southwestern United States does cool down just a touch as we enter phases 5 and 6. In terms of precip, you can see that we do in fact have sort of more variability and not so much certainty with that, but you can see there is a distinct area of storminess and above average precip sort of in the Ohio Valley region into the southwest of that, especially as you enter phases 5 and 6. And another area that does see sort of increased precip is the Pacific Northwest, or the extreme Pacific Northwest, which includes the states of Oregon and Washington, which does stay consistently above average in terms of precip during these three phases. Now moving on to recent trends. Recent trends in our weather and how our atmosphere responds to these certain variables is very important in determining how our winter will shape out. One thing that you might have noticed is over the past few winters especially, you've noticed a very cold theme for the upper Midwest. States like North Dakota, South Dakota, Montana, Idaho, they have just not been able to catch a break with these brutal winters over the past 5-6 years, and you would not be wrong in thinking that. In the past 20 or 10 winters actually, that area has consistently seen below average heights and aka below average temperature anomalies, while the southwest, southern third of the country, and also the southeast and mid-Atlantic have seen, in general, above average temperature anomalies and ridging. And actually, when you look at the 30-year trends for the entire lower 48, the only area that has not warmed from climate change has been this little pocket right here, because of those very below average anomalies that you're seeing in the fall and winter, which is really just skewing the temperature trend, because the rest of the country is warming at a very fast clip, especially Alaska, But you do just have this one pocket right here that's refusing to warm at all. And so that's very indicative of sort of a long-term shift we're seeing, and basically a long-term tendency we're seeing in the atmosphere to promote cooler than average conditions in this area right here. Now let's switch to October snowfall cover. So this is a measure of the Siberian snowfall extent, and you can see this goes up until about late October, last updated October 18th. So it's been a while now. The latest update should be coming out soon, but you can see that 2020, 2021 is right around the middle of the pack, if not a bit below average. And in recent years, we have seen a distinct trend to be seeing above average snowfall anomalies, especially in October. So we do know that in order to see something really impressive, you need to see pretty much above average to well above average Siberian snowfall cover or snowfall cover extent, because above average snowfall, according to the research from Dr. Judah Cohen, does promote a weaker polar vortex, and that can play a key role in disrupting the jet stream and really forcing that Arctic air to come plunging down into the middle latitudes instead of staying locked up in the Arctic region. And you can see that this year, with the October snowfall cover being right around average to slightly below average and melting expected to continue for the next week or so, it definitely looks like that October snowfall cover does not look very favorable to promote any sort of stratospheric weakening or stratospheric warming, thus weakening the polar vortex. So that is one more sign that this winter, the chance of a really sudden stratospheric warming event, which would disrupt the polar vortex, it does look quite low at this point. Now, Arctic sea ice, this is where you sort of have the other counterbalance, because 2020 has been an absolutely historical year in terms of Arctic sea ice. We are, in fact, lower right now than the groundbreaking year of 2012. It's just absolutely insane what we're seeing in terms of record low sea ice. These are values that you just almost never see. Really quite remarkable. And when you look at the correlation with some of the lowest sea ice extent years for the month of March, you do sort of see a trend where you have that ridge really push up into the higher latitudes, forcing that cold air to really sort of invade and dig down deeper into the middle latitudes of the country, really sort of pushing that colder air past the Mississippi into finally the mid-Atlantic and Northeast. And this is shown in the upper level pattern right here with that troughing sort of trying to extend here and that ridge being suppressed just to the south. And you can see also over Greenland above normal heights, which does indicate high latitude blocking or a negative NAO in the month of March. So that is also another wildcard factor, because with those very low Arctic sea ice years, you do sometimes tend to see some high latitude blocking forming in the latter half of winter. Now, finally, let's switch to the models. What do the models think of this upcoming winter? Last year, many meteorologists, including me, were predicting a very cold and snowy winter, a relatively snowy and cold winter for many areas east of the Mississippi, and that simply just did not pan out. The only really resource that sort of correctly predicted a blowtorch sort of winter for the Southeast especially were the long-range operational models. So it would be foolish to not look at what they're thinking and really applying what their thoughts for this upcoming season. And starting off with the North American model, the NMME, this is the 2-meter temperature anomaly forecast for December, January, and February combined, or averaged out. You can see two very distinct themes right here. Very cold in Alaska, and then very warm for almost the entire lower 48, with only the Pacific Northwest seeing some sort of resemblance of average conditions. So that's interesting. And you can see it's also indicating some well above average temperature anomalies for the Southeast, the Mid-Atlantic, the Northeast, the Midwest, the Great Plains regions, the Southwest, Texas. Basically, the entire lower 48 is predicted to see above average conditions according to this model right here. Now switching gears to the CFS, another North American model, and it's a bit more aggressive with that cold. It does shift, it still has those very below average anomalies over Alaska, but it also has it shifted more into Canada. And this is sort of more typical of a La Nina year. Usually with La Niñas, you do tend to have very cold and snowy and favorable winters for Canada, and that is something that the CFS is showing right here. Also note the similarity, the widespread warmth in the lower 48 in the North American NMME, and with the CFS also widespread warmth in Texas, the Southeast, the Mid-Atlantic, the Northeast, and the areas projected to see below average conditions really only being the Pacific Northwest. So good model agreement there. Now here's the Jamstack. The Jamstack really just paints a blowtorch sort of picture. I think this is definitely overdone in terms of its temperature anomaly forecast. I do believe that we will see below average conditions, especially in Alaska. But I do like its portrayal of well above average conditions in basically the entire central and eastern and even western part of the country for this upcoming winter. I really do find that I do really quite agree with that forecast. And finally, here is the European model and its forecast. You can see, again, a bit overdone. It's only painting average anomalies for Alaska, which I think is a bit too high. I think we will be seeing substantially cooler than average anomalies over Alaska and Western Canada. But again, the same exact theme with the European. Widespread warmth in the lower 48. So very good consensus among the models here. All four major long-range operational models are all agreeing that we're going to see above average conditions in the Northeast, the Mid-Atlantic, the Southeast, Texas, the Great Plains, the Upper Midwest, and all of them agree that the only area that has a shot of seeing below average conditions is the Pacific Northwest. So that sums up part 2, guys. I hope you enjoyed. You got a better idea of what's going on this winter, and sort of got a better picture of the wild cards at play and what could mess with this forecast. But one thing I do want to point out is the very remarkable model consensus we're seeing here, which is something you don't typically get. Many winters you have one model indicating lots of troughing, one model indicating lots of ridging in one area, but this winter the models really are in consensus. That does not mean that this is what's going to happen. There's many other factors the models aren't really that good at looking at, but this does provide a valuable tool in indicating confidence and what areas are going to be much more prone to seeing these above average conditions. So that's it for this video, guys. I hope you enjoyed. Please stay tuned for my winter forecast, which should come out tomorrow, which will basically have all the fancy maps and summary of what's going to happen. So have a great day, guys, and I'll see you next time.